Hi, this is a chemistry video on the effect of concentration on rate, also known as the rate law. So let's what are we talking about here? Let's use an equation, a formula, to get us in the mood or to give us a sense of what we're talking about here. So here's a reaction. You've got the ammonium ion, and if you're going to go into chemistry, you should learn the nomenclature here. This is the ammonium ion. This is the nitrite ion. NO3 would be the nitrate ion, but NO2 is the nitrite ion. It's in solution, it's aqueous. This is a gas, this is a liquid. This is nitrogen gas, this is water. So the ammonium ion plus the nitrite ion yields nitrogen gas and water. All right, that's the basic equation. Now what we find is that the reaction rate for this is proportional to the concentration of the ammonium ion, and it's proportional to the concentration of the nitrite ion. It's a one-to-one kind of relationship. As the concentration of ammonium goes up, the reaction rate goes up, or the concentration of the nitrate ion goes up, the reaction rate goes up, and vice versa if it goes down, and so forth. And so it's what we call a linear reaction. And so, as you may know, if you've done enough of this sort of thing before, is that when we have a directly proportional relationship, then all we have to do is stick a constant in there, and we've got an equation. So the reaction rate is a constant of some kind, times the concentration of ammonium ion times the concentration of nitrite ion, and that's going to be an equation. And so, by the way, the concentration is usually in molarity per second. Molarity per second, where 1 molar solution is 1 mole per liter. All right? So, in general, we can say that the reaction rate is going to equal a constant times the concentration of whatever substance A to a certain power times the concentration B to a certain power. Now, in this reaction, the one we just showed, the power is 1, right? We don't write it when it's to the power of 1. So if there's nothing written, if there's no exponent, it's called an exponent. If there's no power, no exponent there, then it's to the first power. And so in that case, for the nitrate or nitrite ion, it's to the 1 power, the first power, and the ammonium ion is also to the first power. So we say it's a first order. It's to the first order. So nomenclature again. What is the K here? We call K the rate constant, and it will be constant for a particular temperature. Now, that constant is going to change because the reactions go faster as temperature increases, right? But at a given temperature, the rate constant is going to stay the same, but the constant is going to be different at different temperatures, and of course it's going to be different, as we'll see at the end of the chapter, if there's a catalyst present. So, but it's constant for a particular temperature, rate constant. We already know that bracket A and bracket B are concentration of A and concentration of B. So M and N are called reaction orders. And there's no way to know what these are from the formula. You have to determine them experimentally. So in the ammonium ion plus the nitrite ion, experiments have determined that it's a linear relationship. As the one goes up, the other goes up by a certain proportional amount. So we have to determine what M and N are by experiment. But again, these are the reaction orders, M and N. So in the previous example, where it was both to the first power, that was a first order. But if it was squared, that would be to a second order. Now, usually it's either 0, 1, or 2. If it's zero order, that means the concentration doesn't change it at all, because anything to the 0th power is 1. And so if the order is the 0 power, the 0th order, then it doesn't matter what concentration you have. It's not going to change the rate of the equation as long as it's there. A first order means it's proportional, that it's as one goes up, so the other goes up proportionally. And then second order means it goes up exponentially. So for every increase, it squares the rate. or if it's cubed, if it's a third order, it cubes the rate. You can have fractional, like half to the half order, but that's more unusual. All right, so this is the formula to know. This is the big takeaway from this video and from this section is this formula right here. There is something called the overall reaction order, and it is simply the sum of M and N, and what if there were more there, the sum of them all, and we call that the overall reaction order. So in the equation we started off with ammonium and nitrite, since both of those were to the first power, the overall reaction order would be 1 plus 1 is 2. Now I know that's very difficult math, but try to concentrate. Concentrate. 1 plus 1 is 2. So that the ammonium nitrate equation is a second order overall reaction equation. All right, so some details to finish up this video. The units of the rate constant are going to depend on the overall reaction order. So what are the units of K? Well, it's going to vary. It's not going to be the same in every rate law equation, and so you have to figure out what it is depending on the powers especially come into play. In general, the units of the rate constant are going to be the units of rate, which is molarity per second, divided by m to the power of the overall order. How did they get this? Well, to some extent you don't need to know because ours is not to question why. Ours is just to memorize or die. But this makes sense because if you look at the equation here, what are the units of the equation? Well, you've got the rate in molarity per second, and then you've got the concentration, which is either going to be molarity to a power. So if you have molarity to a power and molarity to a power, and the overall order, overall reaction order is going to be the powers added together, and so the rate, so K, what are the units of rate of K? Oh, I'm sorry, what are the units of K going to be? It's going to be molarity per second divided by molarity to the total power. So that makes sense. What we've said here, that's where that came from. Basically, the units have to work out. You know the units of concentration, and you know the units of the rate. And so the K's got to be the units that make it all work in canceling things out. Finally, like I said, reaction orders are usually 0, 1, or 2, but they can be fractional or more. Well, this has been a video on the rate law. What is the rate law? Well, the rate law is, this is the rate law right here. This whole thing is called the rate law. Thank you.